Hi, and welcome to today's lesson on the Iceberg model. My name is Ian Lowe, and I will be explaining what is the Iceberg model in systems thinking, and how we can use it to solve complex problems. The Iceberg model is a concept often used in systems thinking and other problem-solving approaches to represent the idea that there are visible and hidden aspects to any complex system or problem. It draws an analogy between an iceberg floating in the water, where only a small portion is visible above the surface, while the majority of its mass lies beneath the water, hidden from view. In the context of systems thinking, the iceberg model serves as a visual metaphor to help people recognize that many important factors and elements may not be immediately apparent but are crucial to understanding and addressing complex issues. The iceberg model typically consists of two main components. Above the waterline, which are the visible aspects. This represents the visible and easily observable aspects of a problem or system. It includes the symptoms, events, or outcomes that are readily apparent and often the focus of initial attention. People tend to address issues at this level because they are readily observable and may cause immediate concern or frustration. Next, we have what is below the waterline. These are the hidden aspects. This represents the underlying and less obvious factors that influence the visible aspects. It includes the root causes, systemic structures, dynamics, and interconnections that drive the observed symptoms or events. Addressing issues at this level involves a deeper understanding of the underlying complexities and dynamics of the system. Let's take a deeper look into how we can apply this in problem solving. In our case, we will use the four-layer model. These are events, patterns, underlying structures, and mental models. Events are above the waterline, or what we call the visible aspects. This is the top layer of the iceberg, visible above the waterline. It includes the aspects of a situation or system that are readily observable, tangible, and easy to identify. These are often the symptoms or outcomes that draw our attention because they are visible, immediate, and sometimes problematic. Examples might include visible behaviors, physical manifestations, or readily apparent consequences of a situation. Just below the surface, you find the second layer, which consists of patterns and trends. Patterns and trends are the recurring behaviors, occurrences, or data points that emerge from the visible aspects. They represent the regularities and consistencies that become evident over time. Identifying patterns and trends helps us understand the regular behaviors or occurrences associated with the visible aspects. Further below the waterline, we have the underlying structures, which encompasses the systemic structures and dynamics, like the underlying organizational, process, or structural elements that shape and influence the observed patterns and trends. Deepest below the waterline are the mental models. Mental models represent the fundamental and often hidden factors that give rise to the systemic structures and dynamics. Identifying these root causes is essential, because they provide the foundational explanation for why a situation or system functions the way it does. Addressing root causes is key to making lasting and effective changes to improve a situation or system. In summary, the iceberg model serves as a useful metaphor to remind us that complex situations or systems have multiple layers, with the visible aspects representing only the tip of the iceberg. To truly understand and address complex problems or situations, it's essential to delve deeper into the layers beneath the surface, uncovering patterns, systemic structures, dynamics, and ultimately, the root causes that drive what is observable. This holistic understanding allows for more informed decision-making and effective problem-solving. Let's consider a technical problem of frequent server crashes in a cloud-based application. We can apply the iceberg model of events, patterns, structures, and mental models to understand and solve this problem. At the events layer, we can see the symptoms. The application experiences server crashes regularly. The observable issues are downtime, user complaints, increased support tickets, and lost revenue. Next, at the patterns layer, we notice some recurring behavior. We can analyze the server logs and error messages to identify recurring error codes, or specific conditions leading to crashes. We can also determine if crashes tend to occur during high traffic periods, specific user interactions, or after recent software updates. We should also identify which application modules or services are most frequently associated with crashes. Lastly, we should also look at user patterns and investigate whether certain user behaviors or actions trigger crashes more frequently. After we have identified the patterns, we can start looking at the structures. At this point, we can review the application's source code for potential memory leaks, resource mismanagement, or other software defects. We should also evaluate server resource allocation, like CPU, memory, and storage, to ensure it matches application requirements. We then assess whether the application architecture can scale to accommodate increased traffic and load. At this stage, we should also examine dependencies on external services, libraries, or APIs for stability and potential issues. When we have collected the information from the above layers, we would start to determine the mental models. At this point, we need to see whether there are any assumptions about system behavior, scalability, or resource usage that may not align with reality. Next, we investigate if there are cultural or organizational factors affecting the way server crashes are perceived, reported, or addressed. We should also evaluate the team's collective understanding of the application's architecture, dependencies, and best practices in system management. By employing the Iceberg model, we can systematically uncover the underlying causes of server crashes, including code defects, resource limitations, architectural issues, and potential misaligned mental models, and then implement solutions that not only resolve the immediate symptoms but also prevent future occurrences, leading to a more stable and reliable application. It is important to ensure that the team's mental models align with the system's actual behavior, and that there are no false assumptions or knowledge gaps.